Hello everyone, and welcome to the solution for the singly linked list cycle check problem. In this problem, you were given a singly linked list, and you had to write a function which takes in the first node in a singly linked list, and then returns a boolean, indicating if the linked list contains what's known as a cycle. And that cycle is when a node's next point actually points back to a previous node in the list. This is also sometimes known as a circularly linked list. You were given this linked list class node. Okay, so here we have our solution and the code to go along with it. Let me go ahead and read through just the basic explanation before we start coding it out. In order to solve this problem, what we're going to do is have two markers traversing through the list, marker 1 and marker 2. Those are actually going to be the variable names. Then we will have both markers begin at the first node of the list and traverse through the linked list. However, the second marker, marker 2, will move 2 nodes ahead of every one node that marker 1 moves. By this logic, we can imagine that the markers are racing through the linked list, with marker 2 moving slightly faster with a different step size. If the linked list has a cycle and is circularly connected, we will have the analogy of almost like two runners on a track in the field, with marker 2 being the faster runner. And in this case, the marker 2 will eventually be lapping the marker 1, and they will equal each other. If the linked list has no cycle, then marker 2 should be able to continue on until the very end, never equaling the first marker. So let me explain that basic logic one more time for you. You can essentially imagine having two tracks. One is a straight single line track, and the other one is a circular track. If you had two runners on the track, one very fast and one a little slower, then if the track was just a single straight line, in this case it was just a list with no cycle, then the runners would never actually meet up. The faster runner would just go ahead of the slower one, and they would never actually meet up. But if you have a cycle, or in this case a circular track, then eventually that faster runner, in our case marker 2, is going to go along that track, that linked list with a cycle in it, and you'll eventually pass or lap marker 1, and they're going to eventually meet, and in this case equal their values to each other. So that's the main logic here. So let's go ahead and implement this so we can get a better idea of what's going on. Jumping to a code notebook, let's begin by saying def, we'll say cycle underscore check, and take in that node. We'll begin both markers at the first node. We'll say marker 1 equals node, marker 2 equals node. And then we're going to go until the end of the list. We're going to say while marker 2 does not equal none, meaning we haven't reached that tail, and marker 2 dot next node does not equal none, meaning marker 2 isn't just about to finish. Then we're going to take a note. We're going to say marker 1 is equal to marker 1 dot next node, and marker 2 is going to be equal to marker 2 dot next node dot next node. That's essentially how we're going to make marker 2 go a little faster. Marker 2 is going to check one node ahead of marker 1. Then we want to check if those markers have actually matched. So if marker 2 is equal to marker 1, we return true. And there's might be a case where the marker ahead reaches the end of the list, meaning there's no cycle there. Then in that case, we just return false. So let's break this down one more time. We have two markers. They start off at just the node. And then we clarify until marker 2 doesn't equal none, or its next node is not equal to, sorry about that, none. Then what's going to happen is we'll check marker 1's next node and marker 2's 2 nodes ahead, meaning this one is essentially that faster runner on that lap. Then if marker 2 is equal to marker 1, we just return true. Otherwise, they never met up. Marker 2 never quote-unquote lapped marker 1, so then we just return false. We can go ahead and run that. So let's go ahead and test this. I'll zoom out a bit. And we'll put in our node class, and then we're going to go ahead and copy and paste the test cell from the notebook. And there's the test cell. So we basically just check against the cycle and a linked list that does not have a cycle. And if we run this, we get all test cases passed. All right, that's all there is. This is a bit of a trick, but it's a really good way of thinking about this problem. And hopefully that analogy of two runners running around the track or running down a straight line, with one of them being basically, in essence, a node faster here and seeing if they meet up, is a good way of thinking about this particular problem. This is a really common problem in interviews, especially interviews testing linked list knowledge, so make sure you really know this one, and it'll be really great if you can explain this analogy to whoever's interviewing you. Alright, that's it for this lecture and this solution. I will see you at the next one. Thanks everyone.